Chapter 5 discusses how we can manage GIS data specifically focused on the vector data. So in this video, we are going to review different types of spatial data related to vector format, and then we are going to see how the attributes in the relationship with the vector data could be possibly queried or analyzed. So vector data is a combination of three different types of data. You either have points, you either have lines or polygons. And every single one of these helps to represent a real world phenomena. So we have coordinate system that help us to determine where these points, lines, polygons are located, and then we can just build on this promise of displaying the real world phenomenon in GIS by using a combination of these three. And then in addition to the spatial data, we have a table that is connected to that. And for example, think about states in the United States, and each state has its own boundary. That's great, but then you may want to also save additional information. For example, state ID codes, or maybe population or some other things for a specific year. We can put those into the attribute table. Anytime you click on any of these polygons, then not only the state name will appear, but also other attributes. So the spatial data known as feature class in GIS, the vector data is also known as feature class, and that is a collection of similar features stored together as a data set. So we have a polygon layer as well as the attribute table, both together creates our feature classes. If you go back to the GIS kind of modeling in the maybe past decade, you'll find one model is very common across the platform, known as spaghetti model. And recall the spatial data format, vector format. That is how those used to be built. And that's a simple data format, and its state is recorded as a separate object, and there is no relationship between, for example, Oregon and Washington. However, that is how the GIS data format started. Today, we are using a little bit more advanced version of that. It's known as topological model. Topological model not only save the boundaries, but also save the relationships. So how the features are spatial related are very important. So we know, okay, what states are adjacent to the state of Washington, right? So that is something that we can save in the topological model. And then using that help us to avoid some of the data errors. For example, we know that there shouldn't be any overlap between the state boundaries. So if there's one overlap somewhere, we can easily identify that. And GIS data are different because files can be very large and they're often shared by multiple users. So we want to make sure that we are using a correct version of the data file or layer. They may come from different sources, so it's very important to keep track of the metadata or information about the layers, who actually created that, when was the data created, what's the accuracy. And some data sets may be stored on your local computer. However, it is always preferred to have them connected to a server, so any change you make would be also updated on the actual original data. And then in ArcGIS Pro, what you can do is to hopefully use the catalog, and catalog is integrated into ArcGIS Pro, so it helps you manage the data much more efficiently. And there are some tips for managing data in GIS, and you can read the actual textbook, but basically we don't want to never use the space in the name. We don't want to use a name that is random. We want to use names that are descriptive. For example, if you use a method, if you use a specific location, you want to include that in the name. And for the folder names, of course, space is always discouraged, and in this case, you cannot use space. If you use a space in the folder name, you're going to get an issue of loading the data. You may not be able to actually see the data in the ArcGIS Pro, even though it might be visible and accessible through the Windows OS, but it's not accessible through ArcGIS Pro. And you want to keep the folder names short, right? So make them simple. So the file extensions within ArcGIS Pro can be displayed. However, if you want to do that, you have to go to the Windows Explorer options and then uncheck the hide extensions. The ArcGIS Pro project file known as APRX, that's what we are going to see more and more. However, you may also be able to see the other common files that are being used or produced by ArcGIS Pro. For example, XLSX, that's an Excel format. And then PNG or TIF, those are the imagery raster format. To be able to access data appropriately, we want to make sure if one layer is being worked, someone is working on a specific layer to make some changes or edits, that layer cannot be accessed by someone else from another, maybe ArcGIS Pro software. So we want to make sure that you have set the accessibility the right way, so it's not kind of complicating things for the server access. And many data you get for the purpose of your projects or somewhere you're working with might come as a zip folder, and make sure you extract those files before you can see them, you can access them within ArcGIS Pro. If they are zipped, that's great to transfer between different platforms or even put it on a website to be able to download it. However, after you download that zip folder, you have to extract it, so then single files or folders within that would be also accessible. If you want to do some important exporting, the process that you do creates a copy of the data sets. So if there is a format change, you want to make sure that you are clear on that. You know what is the actual name or what is the location of that. If you use the default location, that is going to be within the geodatabase of the project. So next time you want to find that layer, you have to go through that route. Sometimes if you wanted to use that layer that you created, exported in another project, it will be preferred to export it in a new location that you save as a new folder, and then the location of that on your Windows Explorer. Very important to kind of touch base on the idea of scale in the GIS. So when we talk about the source scale, we need to pay attention to the actual scale of the data. So if you have a large scale data, right, and these are representing some of the large scale values, right? So 1 over 25 million, 1 over 5, 1 over 50, 1 over 5 million, 1 over 50,000. If your data is from one layer is from 1 over 25 million, basically a very small scale, right? So the actual number is small, but the features are also, they don't have the same level of change compared to the larger scales. For example, 1 over 50,000. It's pretty good in terms of how much detail you can include. But then if you combine these together, you are going to come up with something like this. So the map for one layer does not have a lot of changes, for the other one has all of the different changes. So that's why you need to pay attention to these when you are building different layers and know, okay, the combination of different layers with different source scale may become problematic when you zoom into the specific region. And to make sure that you can incorporate your Excel data set with the spatial information in ArcGIS Pro, what you can do, you can add a table and create a point layer for the rows or for the records of that table. And that is being done based on the coordinates. So in this case, we have latitude, longitude, and those are used for X and Y. And then of course, we have to identify what will be the coordinate system. In this case, the coordinate system is the geographic coordinate system, North America, 1983. So after we do that, and then we create the point feature set, we can work on the point feature set. We cannot work on that table because that's not spatial data. And this process of converting attribute information with spatial data to the feature class known as geocoding, and in geocoding could be also based on standard format of the addresses within the United States or other parts of the world. So you have to use those names and standards and then convert your tables to the feature data sets. Kind of reviewing the value of doing spatial analysis and working with the spatial information from different layers. One would be to extract data. So to extract data, what you can do, you can go to the attribute table, build a query. For example, we want to find states with a population in 2014 that are greater than 100,000, or let's say cities to make more sense. So that is going to give you a subset of the original data if there's any matching, right? Or you can also work with the spatial information. You want to just click one part of that input layer with that double ring. So it's going to give you that output, or you want to erase that. So it's the opposite of that. So you don't want that part. So take that intersected area and take it out. If you want to merge two layers that are in the coordinate system or right adjacent, it is going to give you a larger, of course, layer based on the combination of these. And usually used for adjacent layers. If you don't have adjacent layers, then it's going to be a little bit different because you will have a void space within those two polygons. And that is going to be a bit problematic. And the kind of details of how to merge, it would be, of course, based on one of the layers and then the attributes, because we have two different layers that are two different attributes. Now we have to decide what attribute you want to include. And another thing you need to take into account is what is the field that is going to be used. And that is going to be another very important issue that you need to be aware of. If you append, the target data set is already, target data set already exists and no field mapping is available. And then the fields in the source that don't match target fields will have their data drop during the append operation. So basically, if something is not matching based on the specific common field, there's no outcome when you actually finalize the appending. Generalizing is a good idea when you have detailed information, very detailed information, let's say very large scale, 1/10,000, but then you don't want to display information at that level. You want to show more broad view or think about the word view. So you don't have to store all of those details. So what you can do, you can generalize your input layer. So when you zoom out from that polygon with all those details, basically what you can see is just the boundary surrounding that. So you don't see all of those zigzag or detailed acute angles. Dissolving is another good way of simplifying information. For example, we have all these polygons on the same attribute, they have the same value. So what we can do, instead of using single polygons for every one of these, we can take care of the common boundary and then just get rid of that common boundary. So we create a larger polygon for all of these small polygons. So it makes the analysis much more easy, makes the visualization much more appealing, because we don't have those polygons, separated polygons. We have a larger polygon we can work with. And it's very important to understand what is metadata. Metadata is a data set that helps the user assess its purpose and quality. For example, if you create a data, it is going to be very helpful to provide your information, provide maybe where you did create the data, where the data came from, what method did you use, what technology did you use, and when the data was created. So kind of a little bit more information helps when the next time someone is going to use that, they know, okay, if they have any question, they can contact you. If they have any concern about the dates, they can easily reach that, and then so on. So what you can do to include in your metadata when you create that is to include these information, for example, tags, kind of some simple term to explain the data, summary, a little bit explanation about the data, a little bit more explanation could be added to the description. Credits, if someone has helped you with information coming from a specific organization, you add that through the credits. If you want to limit access to the data, you explain that here. The appropriate scale range based on the input data, based on the accuracy, you want to limit that and identify that. And finally, kind of a bounding box, kind of go over the whole area of your layer would be added to the bounding box of your metadata. These are kind of a brief descriptions of types of data used in ArcGIS. Not all of them would be used in all applications. Some of them may be used more, some of them may be used less, but let's think about one example here, Geodatabase, which are the recommended model for storing spatial information, because it helps to kind of keep track of relationships, keep track of topology, and sharing capability within the geodatabase is very strong. It's very important. TINNs or triangulated irregular networks are used for storing 3D surface information. Think about the elevation. So if you want to save the elevation as a raster file, you use TINs and then other types we can review. And going back to the geodatabase, there are different formats for the geodatabase, but what happens here is that you have a very specific geodatabase and you pour all of the layers within that. The layer could include a feature data set, like combination of different feature classes, or it could be a single feature class, for example, cities in this case, or it could be raster data. You can also add the tables within that and then also on. There are 3 types of geodatabases that you can create. However, we basically most of the time are using the file geodatabase within the ArcGIS Pro. You can create the enterprise geodatabase, which is an extension of the file geodatabase, but is designed for server-side management, data management system. The personal geodatabases used to be within ArcGIS map, but they're not being recognized by ArcGIS Pro anymore. So we don't see that option anymore, but it has also another version of the file geodatabase, which does not have a lot of capabilities compared to the file geodatabase. It has a limit on the size of the feature class, 2 gigabytes. So it's really a weak version of the file geodatabase. Shapefile format, we may not use that a lot. However, that's one of the oldest and probably the most popular format in the GIS. The shapefile, when you open it in an ArcGIS Pro and in ArcGIS platform, is going to be one file. However, when you go to the Windows browser, you see several files, 7, 8 files that are kind of all together helps to create that shapefile. So you see that parcel layer in the catalog pane or in GIS platform. When you want to add it, you only see that one.shp file. And when you go to the Windows browser, you see a combination of different files. You have the projection file, you have the table, you have the SHP, you have, so this is DBF is a table. So all of those are part of that shapefile. But because of the kind of complexity and very bad organization of the shapefile, because all these files, if something is missing, the shapefile is basically destroyed. So it's very difficult to, when you have the files on the machines, to keep track of every single file. To share data in ArcGIS Pro, there are different ways you can create and export a map and share that as an image, or you can share that as a web map layer, or you can share the layer within the organization, within a specific group. And so I hope you enjoyed this video. Please review the concepts a couple of times. Make sure you understand every single terminology, and I'll see you in the next video.